All right. Hello, everybody, and welcome back to the stream. I hope everybody is doing well tonight. We are going to pick up this week where we left off last week. We did get a few things done off camera, so we're going to go over those first, namely what we've talked about in the title. So we've got some cool new things to show off, and then we're going to continue with our asset work. I think we only have one or two more types that we have to convert, and then we can get started on the resource half of it. So hopefully that's going to be coming to a close, minus any sort of troubleshooting work that we have to do. All right. With that being said, before we get into that, I do want to just take a quick second and thank the supporters of the channel, starting with our partners who are the highest tier of subscription over on YouTube memberships and Patreon. They are Dustin Punt, Gabby Bashir, and Gerboli's Inc. I would also like to thank all the other supporters listed here on the screen. They are a combination of the other tiers of support over on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. It means a lot. It helps me out a great deal in covering expenses having to do with the channel and the project. So thank you all very much for that support. I greatly appreciate it. With all that said, I do greatly also appreciate you, the viewer, whether you're here on joining us live on the Twitch side or the YouTube side, or catching us on the VOD afterwards. Without you guys, this project would not exist, so thank you very much for being here. And speaking of YouTube and Twitch, we do simulcast to both. This is an interactive stream, so if you have questions, comments, anything you want to chat about, feel free to jump into chat, and we will talk about it. All right. So, with all that stuff out of the way, we are going to talk about tonight string hashing. And I kind of alluded to this on the last stream that maybe we would need to at some point switch to C++, and we have not done that. Maybe in the future, but we have not done that yet. We've implemented the sort of first portion of that doesn't actually require C++, right? So we're gonna talk about that portion, and what we're gonna do is we're gonna get that implemented into all the systems throughout the entire engine, and then if we determine that we really could use the compile time hashing, we'll go ahead and do that. All right, device serial, how's it going? Good to see you. All right, so what am I talking about when I talk about knames and string hashing? Well, let's start with the kname. So I'll open up kname.h here. And you can see here, let me actually close this other pane here. You can see here that I have written up a little bit of documentation on this because it's going to be so widely used. But I'll briefly summarize. Essentially, a kname is a lightweight sort of system to manage strings. And a kname itself is nothing more than a type-deft U64, right? So when we say kname, we're really talking about an integer. And so what a kname is we take a string and we create a hash out of that string. And that hash gives us a 64-bit unsigned integer. And then that is what we use going forward. And we've type-deft this as kname just to make it explicit clear as to what it is. And then whenever those are used, just understand that it's a U64 under the hood. Now, why would we do that? First and foremost, it makes sure that comparisons among these are lightning fast, right? Because all you have to do to compare two knames now is a simple equals test. There is no string comparison that needs to be done. So that's one thing. Also, every time we actually create a kname, which is done by kname create, that string is saved off into a global lookup table along with its generated hash. And so we are able to retrieve that string at any time from its kname. And the advantage there is that string is only saved one place in memory. And so we can actually use and access that kname from anywhere in the system, and we can access that original string from anywhere in the system. And the other thing about that is once the kname is created, that original string is immutable. It is also case insensitive. So when we actually create the kname, we take the lower case form of the string, and we use that to actually create the kname. But we do store off the original string, right? So when we get this back, we'll have the original casing preserved, but only the first instance of it, right? So the advantage there is that we can see what was originally passed in whenever we created this, right? But we don't have to worry about case sensitivity issues when creating the same kname from different spots in code. And so it allows us that sort of autonomy there. And so these are basically going to replace strings in a lot of different places in the code. Not all, but any sort of named object is now going to use knames. And of course, the advantages there should be somewhat clear in that, we just have a simple 64-bit integer representing the name, and that can be looked up at any time, right? So that's basically what this system does. We don't have the compile time version of this yet, which is fine. We just have sort of the first half of it. So this is all done at runtime. So we have a kname create and a kname string get, and that is all there is to the system right now. So if we actually go to our kname C file, it is actually pretty straightforward stuff, right? So our kname is actually created using this. We take a copy of this string, right? Because we don't know what the life cycle of the original string is. We convert it to lower string, which is string to lower is a new function that I added. And then we hash the lowercase string using crc64. Now this is something that's is also new. That we'll touch on here in a second. But it's basically a hashing algorithm, a 64-bit hashing algorithm. And we pass the copy of the string there along with its length, and we get the hash back. And that hash becomes the kname, right? So we save that off. We do make sure that the kname is not equal to 0 when we hash this. If we ever hit this, we do have an assertion here that will catch it. Because we're basically treating a hash of 0 or a kname of 0 as invalid, right? So we're not going to allow a hash of 0. So if for some reason this ever returns that, which is highly improbable, but it could, in that event that occurs, you would just have to change the string slightly and it would fix it. Then of course we get rid of the copy of the string, right? Because what we actually do is when we go to store the string, we are storing the original, right? So we only use the copy for the hash. And then the next bit of this is we use a U64 binary search tree. And essentially what that is it's also something new that we've done, and we'll kind of step into that. But it gives us a very quick way to search a lookup by an integer, right? And so that allows us to very quickly do that, and we can store a lot of different things as the value of that. So the first thing that we do is we check to see, hey, has this kname been created before? AKA, does it exist in the binary search tree? If it does, then there's nothing more to do. If it does not, then we create a new value. We take a copy of the original string, and we insert that into the binary search tree, right? And if for some reason that fails, we bleat about it. And then we go ahead and return the kname. So that is all this does, right? Which is actually, it's a decent amount of steps, right? But some of that is skipped if it already exists, right? So if that hash doesn't exist, it will go ahead and enter it into that tree. Otherwise, it will just use it as it sees fit, right? The other part is the kname string get, which simply does a lookup into that binary search tree. And if it finds it, it returns that string directly. It does not return a copy. It returns the direct string, which is why we're returning it constant here, right? So we should not, we've actually noted this in the comments of this as well, right? So we return that directly. If it's not found, then we return a null pointer, okay? Or, 0. All right, so that is that. Let me catch up on comments. Let's see. You know from Lake that's not weird that you read it that way. My dyslexia kicks in all the time, and I read things backwards like that too. So no worries. I'm not going to say out loud what it is on stream, but yeah, I get it. Let's see. Smudge, good to see you. Coffee Lava, how's it going? Um, is the hashing perfect? I have reason to believe it is. About as close as we can get, right? So I will go into this specifically this, right? Now, I did not write this, okay? So I've included the original bits in here. Reason I did not write this is because I did not want to take the time to figure out all of this, right? So this is a pre-generated table that is used for this algorithm, right? And then this is the actual algorithm itself here. So if you want to know more about how CRC works specifically, look at this implementation. This is actually taken from the Redis code base, right? And so this is a very commonly used implementation of this. And this is the one that I decided to go ahead and use. Just because I didn't see the point in re-implementing this completely from scratch, because I would have wound up with the exact same thing anyways, so I might as well just license this out and give credit to the person who wrote it, right? So this is one of the reasons that I say I am fairly confident that this is about as perfect as it gets, right? Because this is a very commonly used piece of code, right? So, all right. I also put this in an attribution file, and I added that to the code base as well. So this is one of those few things where I'm just like, you know what, it really doesn't make sense for me to write this from scratch. Somebody's already gone through here and figured all this stuff out. The only thing that I don't know is how this will work when considering big endian versus little endian. But I know that this is written with little endian in mind, so I don't know if big endian is going to be a huge issue. We may have to tackle that separately, because I think this table has to actually vary based on that. But I'm not going to worry about it for right now. If we have to slide one out and slide a new one in later, I'm not really worried about it. Thank you for the hydrate redeem. Appreciate it. All right. So that's all we have on CR64. That's a fairly common hashing algorithm. Again, if you're interested in the details of that, feel free to look it up. Okay, so the binary search tree. So the binary search tree itself is set up like this. So we have nodes, right? It's basically set up like you might expect any tree to be. You have a U64 key. This ultimately, in our case, fits perfectly with the kname that we're going to use, right? So in this case, the kname is the key. And then we have this value, which is a union up here, right? And we'll jump to that in a second. And then, of course, we have left and right. Now, we could use an array to do this as well. I may refactor this into using an array if we need to do that down the road. But this implementation is plenty fast enough as it is right now. I don't think this is going to be an issue. So I'm not really too concerned about that at the moment. We have basic operations: insert, delete, find, and clean up, right? So the way that the value works is, since we're using a union, we can either take a pointer to some data, or we can take a string, right? Which both of these wind up being the same size. Or we can take a U64 and I64, right? Both of those wind up being the same size, or anything smaller in terms of integer types. You know what? I forgot to include float in there, though. I should include F32, right? So we can include a float as its value as well. And the nice thing about doing it this way is this is never any bigger than its largest component listed within the union. So this will never be larger than 8 bytes, right? Because we're doing nothing but 64-bit here. So That is more or less the way that that works. If you're interested in that, we do have the implementation here as well, right there. So it's not very complicated at all. It's actually pretty straightforward stuff, I think. We have our insert, our delete, which is actually the most complicated function here. And then we have the find and we have the cleanup, right? So a lot of this stuff is just recursive. So I'm not really going to go into this either. I feel like that's kind of outside the perspective or the scope of what we're really doing here. But I did want to point out that we've added this, right? So the way that this basically works is when it goes to find, it looks for a particular key, right? And if that key is greater than or less than the individual root node that we're looking at, that it either goes left or right down the tree, depending on whether it's greater than or equal to, or greater than or less than. If it's equal to, then we know that we've landed on the match. And the idea is that every time we insert, this tree will make sure that things are in the correct order, so that we can always assume that anything that is on the left side is going to be less than, anything that's going to be on the right side is going to be greater than it. And through that, we can very quickly search through a whole bunch of keys and very quickly arrive at the value. All right, so that is that. All right. Oh yeah, I forgot to mention as well. I did define an invalid kname here to 0. So whenever we are comparing kname values, we can check against invalid kname, right? And that's just sort of defined there for us. Let's see. What are your thoughts on the Discord poll? Surprisingly, a small game seems to win. Unfortunately, question mark. You can veto it, right? Yeah, well, okay, but yes, I could veto it, right? But that kind of goes against the purpose of a poll. Let me actually pull up the poll, because I haven't looked at it in a few days. I was actually sick over the weekend, so I wasn't able to really pay too close attention to it. Oh, there's still 5 days left on it, actually. But let me take a capture of it real quick. All right, and let's see, where is that? Here we go. Okay. So this is it right here. For those of you who don't know, we are running a poll on the Discord server about the first game in Kohi. So if you haven't voted, definitely go over there and do it. The Discord link is in the details of the stream, but I'll also drop a link here in chat on both sides. Assuming the bot actually works on the YouTube side. It doesn't half the time. There it goes. All right. So basically the idea is we either do a small arcade style game initially, just to sort of get our feet wet, but it'll be a 3D arcade game, right? None of this 2D stuff. We're going to do it in 3D. And that seems to be the winning choice so far. And then we have, screw it, start making the big game. And the reason this has a check here is because that's what I voted, right? But it doesn't matter what I voted. I only have one vote, just the same as you guys, right? So that has 21% of the votes at the moment versus the small arcade having 72. I don't see this swinging very violently in the next 5 days, but there are 5 days left. The third option, of course, is to do neither and to just keep adding stuff to the engine, which has a little bit more support than I thought it would. I kind of added that in there as sarcasm, but that's actually got a little bit of traction anyway. And so, if you haven't voted on that, I would greatly appreciate if you would. All right. Thank you for reminding me about that, because I almost forgot to bring it up. F the poll, just do the big game. I know Coffee Lava. That's what I want to do. Every part of me wants to do that, but if we have to make a small game, we're not going to go like super crazy with it, right? We'll keep it very small and simple, just to sort of test it, right? But if you were to start the big game, do you anticipate going back and forth between the engine tweaks and game development? Absolutely, yes. I imagine we'll discover bugs and weak points in the engine once game dev starts. That's the idea. Yep, that's the whole idea. So the idea with starting with a small game was, kind of that we would use that to discover, bugs and design flaws and issues like that, right? And so that's kind of one reason we can do it that way. We'll discover those same issues if we make the big game, though, to be honest. Doing the small game will give us practice technically releasing using the engine, right? So in terms of release, we'll get a little bit of extra experience in terms of releasing with this engine there. But yeah, outside that, there's not really much of a difference. Other than, release date of the game. Voxels for the small game sounded fun. That's probably not going to happen. So the small game would probably be something that's based off of primarily the feature set we have now. I wouldn't want to add too many features. There's a couple things we'll need to add still, but I don't want to add like too many features for that. All right, so that's Kname. So the next thing that I need to discuss is in asset types. So we made some changes to assets in general to use these knames, right? So with the advent of this, we have the name as a kname, the package name as a kname, and then we also removed the concept of fully qualified paths or names, right? The whole thing where we had, package.assetType.asset name, we removed that. We ultimately decided it was going to be too restrictive. We kind of came to that conclusion in the last stream. That stuff's been removed. So now whenever we request an asset, we request it by name and we request it by package name and type, right? So all of this information has been moved out of metadata into the core asset type itself. And then the metadata just has some extra additional stuff that doesn't necessarily need to be here. So I started kind of messing around with the idea of tags too, which are a series of knames. We don't have any way to use these yet, but it is something that I wanted to get in there too, so that we could search, we could tag different assets and search by tags and things like that. But that's a little bit more for the future. Let's see. I feel like the only concern with making the big game first is that if you decide to do a massive overhaul of the engine after the big game is complete, there may be pressure to support the big game with newer versions of the engine, which could maybe restrict progress. But maybe that's a bad take. So in that case, I wouldn't do it that way, right? So what I would do is when I release the game, a version of the engine gets cut at that same time, right? So we cut a release of the engine itself and all the different components of it. We cut a release at right then and there along with the game, and those two are married together essentially, right? So if we need to patch the game or we need to update the game, we work against that version, right? So let's say we release our first game against version, 1.1 of the engine, right? And then another 6 months pass and we move on to version 2 of the engine, right? For example, we would not then take that game and move it up to version 2. Because generally speaking, that would be like remaking the whole game, right? If anything, if we wanted those features, we would probably backport those features to a previous version of the game. Depends on what the features are, right? But generally speaking, you kind of want to keep the game's release with a version of the engine, and those things are coupled and they never really separate. So if you have to patch the game or you have to patch the engine, to patch the game, you sort of do both at the same time, and you always keep those things connected. You don't generally step to a whole new version of the engine. And you'll hear people that use, existing engines now that, will kind of follow that same thing. Like, generally speaking, you wouldn't want to start your game development project on Unreal 4 and then 6 months before release move it to Unreal 5, right? You generally wouldn't do that. So that should alleviate that concern, right? Good explanation. Awesome. Okay. Zoommaker, how's it going? Started making a 2D physics engine, then realized it's so trash, so now integrating Box 2D. That's fine, but I mean, you probably learned some stuff from it, right? So it's not wasted time. You could always use Box 2D as your example, and then, use that as motivation to create your own if you wanted to. Or if you really decided you don't want to do physics from scratch, that's fine too. Small or big game, will there be dinosaurs in it? Probably not. This isn't Ark. Nothing that complicated, I assure you. All right. So, we've removed the fully qualified asset names. We now have these. Asset metadata, we covered that. Let's see. I think we've covered most of the rest of this stuff here. All of our importers and things like that have also been, and our asset handlers have also been updated to work with knames. Speaking of that, the asset system has also received some updates in terms of interface. So when we request an asset, now we say, okay, I want an asset of this type from this package that's named this, right? Instead of providing just the one string, we provide those different pieces. Incidentally, we can also, and I haven't fully tested this out yet, but we can theoretically provide 0 as the package name, and it'll just search all the available packages and return the first one that it finds with that asset name. So that is also another way that we're going to allow things to be loaded. We'll see if that winds up being useful or not. It'd be something very easy to back out without even an interface change. In terms of releasing, we have package name, asset name released. That's pretty straightforward stuff. Yeah, and that's pretty much, I think that's pretty much it in terms of everything we did offline. Most of the other stuff is literally just incremental updates with that. One more thing is the asset manifests have changed a little bit. So we'll use the testbed one here. So you'll notice that we omit type information here. And that's because the actual package system doesn't care about the asset type, nor should it really. The type really only matters at the upper level once it gets beyond the VFS. And then we actually start parsing out that asset type, right? So I didn't see a need to include it here. I also removed it from all of the asset systems, or I should say the packaging systems internal tracking as well, right? We don't store that information anymore. Now it's just name and path, or if there is a source path, we provide a source path. So I did go through and update all of these painstakingly the hard way. The other thing that I did is, and I haven't completed this yet, but I will show you where we're at on it, is the assets materials. I started converting these guys to be KSON files. More than likely, we'll probably just rerun the import process and regenerate all these files, but I started kind of doing a few of them by hand. All right, let's see. Actually done poly to poly, circle to poly, and other collision detections into area object, but those are box 2D. That's pretty good. Aaron Cato is goated. Oh, we have ads. A few seconds late on the ad screen there. Yeah, so I will answer that question, Zoom, once we come back from ads. I like to pause the stream whenever ads come up so that nobody misses any content, right? Almost done with ads. Realistically got about 30 seconds left, not 40. I'll cut the screen early. All right, and got about 10 more seconds left on ads. And I'm just going to cut the screen early. All right. Ads are dead. So I just like to pause the stream whenever ads come up on the Twitch side, which is once every 30 minutes for up to 90 seconds, depending on region and locale. And so I just pause the stream across the board just to keep the playing field even, right? So nobody misses any content. Zephra, how are you doing? I'm doing pretty good. How about you? Welcome. Zoommaker, I am wondering, what will you do? Use Bullet or something from scratch? 3D is getting really complicated to optimize. Yeah, so admittedly, I haven't fully decided there yet. So thank you for the follow, FM Sharp. I appreciate that. So part of me just wants to use, a big part of me wants to use an existing physics library, right? And I probably I'm looking pretty hard at Jolt right now, actually. And the way that we're going to do that is we're going to do it as a plugin, like we've done for things like Vulkan and OpenAL rather. So either way, it'll be a plugin, right? Now, I could write one from scratch, and I might do that, but I don't know if the value is there to spend the time doing that. That's one of those things that I feel like could be okay not doing from scratch, at least initially. See, and it's actually for the point that you bring up here. So you're saying I actually don't even need an actual physics engine, just gravity is enough for a 2D platformer game, right? So a 3D platformer game's not much more complicated than that, right? So I don't need like full physics simulation for something as simple as a platform game, right? Or an arcade game. So part of me doesn't really want to do that. And I might even maybe fake physics somehow. For a platformer or something like that, we might just have it, stick to geometry as it goes through the scene or something like that. Kind of how a lot of walking simulators work, or like how God of War does it, for example, right? Where they just sort of have geometry and you just kind of slide along that geometry, and yes, you can jump over things, but you're not really jumping over things, right? And then you transition from platform to platform via ladders or something like that. I think we can do that stuff without necessarily having full physics simulation. So for an arcade style game, I think you can get away with that. For something like the big game that I want to do, I am going to need full physics simulation. And for that, I probably am not going to want to use a hand-rolled solution anyways, because of all of the things that I'm going to need. So at that point, I might wind up using something like Jolt anyway. Do you have a plan for the big game? I am in process. I'm in process of kind of writing up. I'm writing up a high concept for it now. And once I have that together, and we'll probably go through this too as well on the even for the small arcade game. Like if that winds up winning the poll, right? We'll go through the same process where I'll kind of come up with a high concept, and then we will spec out a game design document and start building the game, right? But yeah, that's kind of the plan there, right? More than likely, I'm probably going to wind up using a library for that. But it's not going to be quite as simple as you might think, because all those physics libraries are in C++. And our engine is in C. So there's some issues around that. Okay. When it comes to show the capabilities of an engine, physics simulation is easy to simulate and show people. Yes. Yeah, exactly. So it all depends on what we need, right? Have you heard about the Ladybird browser? I have heard about it. Don't know too much about it. Don't use it myself, but I have heard of it. Yes. Bytemap, how's it going? Hello there. Thank you for sharing this golden knowledge and beautiful project setup. Will you be making a games with this engine? And will you be making series for those as well? How soon? Okay, so we're kind of touching on that anyway, so I'll just answer that too. So more than likely, what we're going to do is let me just pull something up real quick, actually. Actually, bear with me here for a second. I just want to pull something up. Let's see, where is it on? Playlists. Okay, so right now, there we go. So right now, the way that this winds up working out is this is a playlist on YouTube, which is probably how most of you found this, right? And we start all the way from beginning where we set up the thing, and then we just kind of keep going all the way up to where we are now. And every once in a while, I go in here and I add the live streams to this, right? That's why we have the episode number in the stream and all that stuff. Looks like I really need to update this. Okay. So it's about 20 episodes off. That seems fine. Anyway, so I think probably what's going to happen is once we actually start making the first game, I'm probably going to end the Kohi series on YouTube at that point, at least that playlist. And we will probably just shift to having like non-playlisted video releases from that point forward, because I think at that point it's not going to make sense to maintain different playlists where we're touching on the game and we're touching on the engine and we're going back and forth potentially in the same video / stream. It's really not going to make sense to kind of keep playlists for that kind of thing. So I think probably what I'll do is I'll end this series there, but it won't technically actually end. It's just not going to be updated there anymore, and there'll just be videos on the channel. I haven't fully decided on that, but that's kind of the idea there. So yes, to answer your question, yes, we will be making multiple games with this. We do have a poll up on the Discord server right now as to what you guys think the first game should be. So if you want to vote on that, head over to the Discord server and do so. But more or less, yeah, we are going to be making at least one, if not two games on this in the somewhat near term, right? So probably what's going to happen is we're probably going to write a small, simpler game first, get that released just to sort of work out any bugs in the engine, work out the process of releasing with the engine, and then we'll start on a larger game. That's the way that this poll is kind of shaping up. So I hope that answers your question. In terms of how soon, by the way, so we have some more features that we need to add to the engine before we can even do the first game. One of those right now is we're sort of redoing our asset system. So we need that done. We really could use some sort of animation system, an animated, like skeletal or just regular meshes of some sort. And I think that's about it. Minus maybe a couple of things that we need to add for lighting, but nothing huge. Let's see. Be very interested in writing a simple gravity collision and bounce physics. Yeah, that would be interesting to do. Highly suggest to add the new videos on some sort of a playlist. That is how I and others will follow the course. Even these long format live videos. Yeah, I mean, maybe I could end the Kohi series at that point and then just start up a new series as I'm working through that game that'll also include engine stuff, but is based around developing that game. Maybe that's the way I'll do it. A lot of people are programming along with. Don't cut us out by removing handy playlists. Yeah, and that's the thing. That's the reason I hadn't decided on whether to do it or not, right? Before I made that decision final, I was going to run a poll on it anyways, but you bring up a good point. Would love to see this in action soon. By the way, I'm a developer in the making. Got to stay humble. But well-versed in C and C++. Would love to contribute in any way at all. Well, I appreciate that. V2 Kohi series playlist. Yeah, right. Is the engine capable of doing 3D? It is in 3D. So actually, because we haven't actually switched the stuff over to use the new asset system, I think, unless I've broken something, I might be able to actually run this. We'll see. Yeah. So this is what the engine looks like now. Now, granted, this is, not optimized or anything like that, right? But, we still have some stuff left to do, right? But this is what we have so far. We've got some basic lighting in, the ability to load 3D models into a scene. We've got PBR lighting along with cascaded shadow maps. We recently added this water here. So that's got reflection and refraction in it. A little bit of surface wetness. I don't have that fully tweaked the way that I want it yet, but we've got some of the stuff there for that. And then, we've got a few debug views like lighting only, where you can just look at the lighting by itself. Normals view, which for some reason the water's messed up. I've got to fix that. And then a view of the shadow cascades, so you can see what the different resolutions of the cascading shadow maps are. You can see those clearing up as we get closer, and getting a little bit blurrier as we fade away. And we also have a wireframe view. So we've got different views. We can also grab objects in the scene and move them around and scale them and such, right? So there's the scale. Here is the rotate, right? So we could just rotate things around. We can also move it around, right? So we've got some basic things in there. We also do have sound, which I don't have anything with sound hooked up at the moment. But we do have a sound engine as well that does have spatial sound capability. So, 3D sound, as it were. So we have that in as well. And I think that's covered most of it, I want to say. Obviously, we do have the ability to render text as well. So this is a bitmap font down here, this debug text here down here. This is what I call a system font here, which is using a true type font. That's how we get these UTF-8 characters. So we do have most UTF-8 support here as well, and in the title bars, things like that. So I hope that helps. A little bit of a demo there as far as where we're at. I know sometimes a visual thing helps. And the only reason I'm able to actually run this is because the old assets are all still in place. I haven't actually switched over everything to start using the new asset system yet because we're still building it. So FPS is limited right now, yes. And also, I have Vulkan validation turned on, which hits the frame rate hard, like really hard. If I turn that off, then yeah, it's a lot quicker. But yeah, validation. I mean, like if I turn validation off, my frame rate jumps by like 300 to 500% depending on what I'm doing. Why support both bitmap and vector fonts and not just vector? Fair question. Because sometimes there are fancy things that people want to do with a font that maybe only has certain a limited subset of characters that would be very difficult to or expensive to reproduce, on the fly every frame. So it might be. I'm trying to think of a decent example, but yeah, I mean there could be like a font that's got like super detailed texturing in like its letters or something, and maybe it only supports numerics or something like that. That might be an example of where you want to do that. Also, bitmap fonts are a hell of a lot faster to render, so there's that too. I basically don't want to limit people, right? If they want to use bitmap fonts, they can. If they want to use the system font, they can. Dr. Elliott, good to see you. Hello. What is KApp? So, the basic structure of the project is, right? So we're looking at the Kohi folder here. So all these Kohi dot are different sort of modules or libraries within Kohi itself, right? So we have the core, which contains all of our types, right? Our base types for assets, our containers, our debugs, like our assertions, our math library, memory management, all that kind of stuff, right? Then we have runtime down here, which is what the application bases itself off. So this is what contains the core game loop, what contains a lot of our systems, what contains our renderer front end, our audio front end, the non-API specific renderer front end, for example. And then we have up here, we have plugins. So the audio backend and the renderer backend are both plugins. So all of our Vulkan code is loaded via a plugin. All of our audio OpenAL stuff is via plugin, right? So the application can choose which plugins it wants to load and which one it doesn't. The UI, the standard UI that we have is also a plugin. So you might have, for example, maybe you want your debug build of the game to have the standard UI, so you have all the buttons and switches, scroll boxes, containers, and stuff like that. But maybe your actual game doesn't require it, right? Maybe your actual game can just get away with printing some text on a screen and having a couple of images that you click and a very simple UI, and you don't need all that stuff, right? The application doesn't have to actually include it, right? We're going to have multiple backends for our renderers. So Vulkan's the only one right now. Eventually we're going to have Metal. Eventually we're going to have Direct 3D. So depending on platform, you can actually choose different ones of these too. Same goes for OpenAL, right? You might want to have Fmod or something as well. So to answer your question, these are all the core Kohi components, right? And then we have these three things called testbed right here, which are sort of testbed right now is sort of our driver application. It's our application that consumes the engine. Okay, and that's split into two main pieces. There are three things here. I'll get into that in a second. But the two pieces are the app and the library. Right. So the app is the actual executable. It's the application itself. So KApp is just a nomenclature that I chose. Thank you for the follow, by the way. To just say, hey, this is a Kohi application, right? And so testbed is the name, followed by Kohi application. This could be called anything. I just called it that to sort of signify what it is. Incidentally, if I use .app or .lib, some OSs / environments don't like that, right? So I did KApp and klib. Anyway, so the application itself is very thin, right? All it includes source-wise is one entry.c file where it loads up essentially a bunch of function pointers, and that's all it does, right? And then the other half of this is the klib, which is where all of the actual application code lives. And the reason these two are split up is because we can keep the application running and hot reload the code as we make changes to the application code library, right? So this is structured in such a way where I can actually recompile this on the fly while this guy is running and have it auto reload. Now, bear in mind with all the stuff we're moving, there's parts of that are probably currently broken, but the design is there, right? So that's why we have that split up that way. And then last but not least is assets. This is going away. This is what the old asset system sort of used, right? So this is where assets currently reside. When we're done with redoing the asset system and the way resources work, this is going away. So the way that it'll work is all of our assets now are going to be in packages, which are going to be packaged with the module that it goes with. So for example, our runtime comes with some assets of its own, some shaders, right? It provides these shaders. Our UI standard library provides fonts, textures, and shaders, right? And then, obviously our test bed will have assets of its own, which are all of these different things. So that's kind of a common setup, right? And so the idea there is that, obviously if you are using the UI standard library, you're going to want these assets. If you're not using it, then why do you need the assets? They shouldn't be necessarily packaged with your game if you're not going to use them, right? They should be packaged with the thing that it comes with, right? So that's the idea there. I hope that makes sense. Is the core only source files, doesn't have any header files? The core is actually more header files than anything else. Although it does have quite a few source files, right? So, we have all of our containers in there, for example. And then we have other things like our assertions, our math library, and all the various things that go along with that. Our memory management, things of that nature. So a lot of, I think I skipped over this. The rationale between separating out core and runtime is we wanted the core to be accessible to external utilities, right? So eventually we're going to have a custom build system that's going to be written in C that we're going to use for this. Instead of using make, we're just going to have our own build system that we write, and that's going to use Kohi core, for example. Or our package generator is going to use Kohi core, but it doesn't need runtime, right? Runtime is all the application-specific stuff. Core is where all of our base types reside. So. Let's see. Loving hot reload. Awesome. Yeah, hot reload is super useful. It has its limitations, of course. The keyboard I am using is listed in the stream details below, but it's the Keychron K2 RGB. This is it here. Let me see if I can... Yeah. So I just have it on red mode now, but it's got, all kinds of different rainbow vomit if you want that. It's got all kinds of stuff. I don't really look at the keyboard while I'm typing anyway. But yeah, it is a nice keyboard. I love it. It's one of the best keyboards I've ever gotten. Not a real engine without ECS. So funny enough that you mentioned that. We don't actually have a ECS. We do have a scene system that has a concept of nodes with attachments, right? Which I suppose you could kind of call it that, but it's not really, right? But what we are going to do is we are actually going to write an ECS, but it's not going to be part of the core. It is going to be a plugin. So if you want ECS, you use it through a plugin. I'm not putting it in the core. That's basically going to be where we're at. But the other thing is, so our scene system, things are written in such a way where you don't even have to use the scene system if you don't want to. If you want full control over how things are loaded and rendered, and the life cycle of those things, you can write all that stuff into the application. You don't even have to use the scene system we provide if you don't want to. It's there, but you don't have to use it. And that's kind of the premise with most of this stuff. All right. Programming on Minecraft. And with the JetBrains JDK hot swap agent, I can almost hot reload any of my changes without having to restart the server. That takes like 30 seconds. Yeah. So hot reloading is really useful sometimes. Like I said, it has its disadvantages as well. You can't change memory layout for one thing. But yeah, it has its uses for sure. All right. All right, I think I caught up on comments. So, where was I? Any changes are stored in RAM too. Yeah, that sounds pretty robust. I don't know. Maybe we'll get to that point at some point, but I don't know. It's managing that sometimes has a lot more overhead than I actually want to introduce. Okay. Am I using Clang Tidy? I am using Clang D to do my format. Clang format. Here we go. Just that. Those are my rules. Okay. So I guess the next thing that we probably ought to do is take a look at our to-do list. In case you're wondering what the outline is to what we're actually doing. So this is what I was talking about. We got rid of this actually, and we have the redo done. So let's see. This is next on the list after we finish asset stuff. So what do we need to do? I was thinking also folders or something we might add for the future, but I don't think I'm going to do that now. I think I'm going to make that a feature item. So let's see. Most of this stuff I'm not going to worry about right now. Images, I'm considering that done. Shaders. These are actually done. The only thing that I need to introduce is hot reloading, which we don't have asset hot reloading yet. So we're going to have to work that in too. But I don't want to do that until we have everything else done. We have system fonts done. We do need to do bitmap fonts. Maybe that's what we'll work on next. Materials. Convert KMT to KSON. We've done that with our serializer. And I think just re-importing will probably get 90% of that stuff, and then we can just tweak the others manually as needed. Manual import of MTL. Might do that at some point. Not really worried about that for right now. Thank you for the follow. And then audio effects and music. Those work completely different than any other asset. So I might actually put a pin in those so that we can move on and come back to those and do those in a separate pass. Okay, so I guess just bitmap fonts then. I guess let's take a look at that. So if we take a look at let's see, these bitmap fonts I think are all part of the UI, which may or may not wind up staying that way. So our bitmap fonts are now these FNT files, right? We want to rename those to KBF for Kohi bitmap font. So let's do. Wait a minute. Let's see. That's a binary. Did I rename that one by accident? Yeah, this should be like, This one should be TTF. I must have renamed the wrong one. This is the one I meant to rename, which is just this file, right? So this is what a bitmap font looks like. We're not going to be changing this format. We're just going to essentially relocate the loader for it. I am going to strip out this fully qualified name that we added here, though. We don't need that. So there's that one, and then there is this one, which also is going to have the same thing. Right? So we're going to rename these to KBF. Just to sort of standardize on file extensions. Okay, so anything that's an FNT is going to become a KBF for Kohi bitmap font. So KBF. So we have that. The only thing we need to do is move what is in, and I'm going to split this. Let's see, it should be font loader, bitmap font loader. Here we go. We basically want the parsing logic that's in here, which is going to be this guy is what we're going to be interested in. We're going to take this out of sort of an import, and we're going to instead change it to a serializer, right? And the serializer is basically going to read in this data and output data that we can then import into our font system. So over here, let's do, I guess the serializer for this is going to wind up being in plugin utils. So for the record, our importers and exporters are going to be in this plugin utils. And that's because this plugin utils is extra stuff that we don't necessarily want to ship with the game, but we will need for like an editor or debug versions of the game, right? So we need a way to import this stuff in a debug build, but we don't want to do that in a release build. That's why we're putting it here. So what we'll do, I guess we could base this off of, this guy. So we can call this importer bitmap font. And that's should be good enough name-wise because we don't actually have more than one type of this. So bitmap font. And open this up, and we'll do a find and replace on, let's see. Well, actually, we should probably strip a lot of this code out of here. So let's see, we want probably from here and then all the way to the end. Strip that out. Strip this out. Strip this out. We don't need to serialize and write anything out as part of this import. It just is what it is. Actually, come to think of it, do I want to come up with our own custom format for this, or should I just leave the parser as it is? You know what? I'm actually going to do that instead. Let's simplify this a bit. I'm not gonna take this through an import process. Let's delete this. Let's keep it simple. Right, so let's get rid of this one. I'm not even gonna do it in here. we're going to let the runtime deal with this. So we can put this in here. We'll need serializer for this is probably what we're going to want to actually use. Thank you for the follow. So let's go with I guess we could use this doesn't really matter. Let's pick a simple one. Let's go with this guy. All right, so we're going to say, instead of case and serializer, we're going to say bitmap font serializer. And same here. All right. All right. So we have our serialize and our deserialize. I don't think we're going to need to do serialize at all for this. So I'm actually just going to do a kassert message false. Right, we're just not going to support serialization for bitmap fonts, period. And so this is going to be bitmap font serialize and bitmap font deserialize. In fact, I might not even have to create this because I could just set the function pointer to... I'm not even going to create this. We're just going to support deserialization. Okay. So the idea here is that we take in an asset, which is this guy. We take a pointer to an asset. We take the file text, and we serialize all the properties of that asset out to it. And that deserialization happens essentially using this logic here. So I'm going to grab all of this all the way to the bottom here, minus the writing the KBF file. Which, now that I'm thinking about it, why didn't I... That explains the KBF file. We already had that, but it has a different context here. I don't think I'm going to do this step. It's not like we parse these things like all the time. We parse like one or two of them on startup, and that's about it, I think. So I'm not really all that worried about it. I'm just going to grab this for now. All right, so let's put this there. Not going to worry about all the errors for now. We'll fix those as we go. The asset type, I do believe we have bitmap font in here. We do. Right? So we need to make sure that that is correct. Obviously. Okay. So the out asset. This is actually using something called bitmap font resource data. So we're going to look at that. We're not going to use this struct directly, but I am going to take a copy of this stuff here, which I think is going to use kerning and glyph. I'm going to take this, and this is, let's see, this is all in font types. So I don't necessarily want to reinvent all of this stuff. Bitmap font pages. So we have pages, page count, and font data, which is all the typeface information. Okay. Each page also has a different file, an ID. It's been about 2 years since I wrote this code, so I'm just refreshing my memory really quickly. So I think all we really need then, we could probably just use I think just this. We may need more than that, but we'll see. All right, so let's go to K-asset types, all the way to the bottom. This is where we're going to add sort of our new types, right? So we're going to say K-asset bitmap font page. Right, we're going to do that here as well. So these are the K-asset version specific of this, right? And instead of resource data, we're just going to say K-asset bitmap font, right? That's the new sort of asset type, right? And then bitmap font page, and then font data. So font data is what contains like the kernings and all that other crap, which where was that? Ooh, that's in runtime. That's not going to work. That's not going to work because we're putting in this in core where it belongs. Core does not have a reference to runtime, which it should not. So we are going to have to actually go into this and move some stuff around. Not a big deal. But for right now, we're just going to sort of duplicate these types, but call them something different. And then we can rip the old types out after we're done. That way we don't break the stuff that's existing, and we can just switch the systems over one at a time. So right below the system font stuff is where we're going to put all this stuff. Now, I am wondering, I think at this point we actually do need the glyph information and stuff, because that's all parsed right out of that file. Not true for system fonts, but it is true for this. Cool Coding Cat, thank you for the follow. Appreciate that. What's going on, Arvis? Naughty chair, how I've missed you. Automod gotcha. Diet Waffles, how's it going? Good to see you. Arcrenato? I hope I'm pronouncing that right. How are you doing? Sergeant Pepper, good to see you. Hope you're doing well. Diamond, good to see you as well. Welcome. Not been able to proceed with your engine or watch you in so long. IRL is such a drag. I feel that. Totally get that. Let's see. Is there any compression for KBI? So the Kohi binary images? Not yet, but we do have into the format. We actually have we have stuff built in to accept compression formats. So we've taken it into account in the actual file format itself. We're just not doing it yet. But we're going to support, some of the more common compression methods. We're just not there yet. We're probably going to need to do that before we ship, actually. Unless we don't have that many image assets, because it's uncompressed RGBA right now. which is not great. Not reinventing the wheel, cooking it. Yes, I like that. That's a good one. Oh, Sergeant Pepper. That's really good. I'm glad to hear that went well. Definitely glad to hear that. Well, I hope your road to recovery is speedy. But yeah, I'm glad they were able to get that for you. Let's see. Do you ever find it hard to continue on Kohi because it gets stale to work on the same big project all the time? If so, how do you deal with that? That's a good question, actually. I do run into that every once in a while, which is usually when I'm like, I really want to work on a game. So what I usually do is I find that I hit that more often when I'm in the middle of a very large feature. And what I do is I take a look at my my to-do list, and I knock off a couple of really quick items, right? And that keeps me motivated to keep going because now I'm like checking off stuff, right? So sometimes I'll put the big feature down for a minute, do those quick items, and then like, cool, I got stuff done, and then that motivates me to keep going with the big thing and eventually circle back to it. That's just what works for me. It doesn't work for everybody, but also that's part of the reason I started doing this like live, is because there's some accountability going with that, right? Going pretty smoothly so far. Looking like, I don't know how to pronounce that. Locutus of Borg with some tubes coming out of your neck. Dang, man, that's intense. Found it a couple months ago. Stupid thyroid. 99% curability rate, though, so couldn't ask for better news. That's excellent. I'm really glad to hear about that. I'm glad that's going well for you. Yeah, definitely make sure to get plenty of rest, and I hope you are on the speedy road to recovery. But yeah, in terms of motivation, that's kind of what I do, right? Sometimes I'll have to put down the big thing and just check off a couple small things. That's actually incidentally why I did the K-name thing that we talked about before, because that was kind of bothering me for a while. And I was just like, you know what? I need to get something done because this asset stuff takes quite a while, right? And so that was an example of me doing that, right? Am I using a garbage collector? No. Definitely not. Coffee Lava would have a heart attack if I did that. If he's still there. That would be like me saying that I'm using ECS. Coffee Lava would chop my head off for that. You're still there. Yeah, okay. I figured you were. Not the most fun thing I've been through, but on the other side of it now. I'm really glad to hear that, Sergeant Pepper. That is legit good news. Sorry you had to deal with that for sure, but that is excellent news. And thank you for sharing. I do appreciate that as well. Conservative garbage collectors are really good though. Depends on the situation, right? Right tool for the right job, right? There are situations where I could see that being useful. Game engines usually aren't one of them though. Maybe in like game code somewhere, but yeah, not core engine code. UE's new incremental GC is amazing. I mean, UE needs some amazing stuff though, because man, that engine is heavy. Tammin, how's it going? Good to see you. Oh, let's see. Okay. Now I remember why the font stuff was all separate in its own types. So the thing we have to remember about fonts is that we have to think about the asset separate from the resource, right? So we have this texture map atlas thing here that shouldn't exist for the actual asset. So we have the actual bitmap font asset, which needs to have this in there as well. But then we also have this font data, which contains all of the individual things that we'll need about the atlas, which these are all things that load in from that file that we looked at before that contains all that data. The texture map is not one of those things. The only thing that needs to be included there would be the name of the asset. So we can actually, let's rename this to, actually, do I even need it? Let's see. So page, why couldn't this just be part of the actual font here? Let's actually do that. Let's grab this. Let's replace that with that, right? We can remove the atlas, right? Remove this entire structure. The font type, we already know it's a bitmap font, right? We don't need this. So we can remove that as well. Font kerning. Okay, so this is something that we need to keep, and font glyph is also something we need to keep. So let's go with bitmap font glyph. Oops. And bitmap font glyph and bitmap font rendering, kerning rather, and kerning, right? And then we'll do the same thing here and here. Okay, so all of these properties make sense to keep. All of these properties make sense to keep. Okay, so this is another thing. So we have bitmap font page. So the font page contains an ID and basically a pointer to an image file. So what the font page is when we take a look at, and I'm going to have to actually open this up in a proper file browser here for a second. Actually, I think our other editor here might actually display this. Give me a second to pull this up here. Let's do... So we've got this, right? So this is what let me close others. This is essentially what we're parsing, right? So it's got all of our glyphs and all that kind of stuff in it. And then we also have a texture that accompanies it. So we have these pages here. See where it says page ID 0 file equals this. So this file essentially is going to be an image asset. That image asset is, let's see, this one, right? And this just contains those fonts or those glyphs that are used for that particular texture, and they're packed, all that kind of stuff. If this was a fairly large font that had, more glyphs that it needed to display, it's potential that we could have more than one of these images. Now, none of the fonts examples here do, but the potential is there that could exist. So we could have an _0, an _1. The underscores number is basically aligns with that ID, right? And so this is basically a page, and that is, how that sort of aligns to the actual font definition. So that's what we're talking about when we're talking about that. And then these are all the individual characters. And then if we scroll down a little bit further, well, I guess this one doesn't have any kernings, right? But a lot of system fonts do. Some bitmap fonts do as well. So when we're talking about glyphs with page IDs, it's what page does that glyph belong to? That can then be looked up from here, and then that points to a file. Now we have just a character array of 256 here. We actually want to use a kname for this, and we're going to say image asset name, right? We'll standardize that. And then when we're actually standing this up and using it as a resource, we can actually just use this kname to say, hey, this is the asset that goes with this page. Okay, so there's that. Also, the face here can also be a kname. So we'll say face. So that's the font face, right? Size, line height, baseline. Atlas X and Y. Glyph count, glyphs, kerning count, kernings. Tab X advanced. That's how far the a tab advances us. So it might be like 4 spaces, for example. And then if we have an internal data or internal data size, I don't think we actually use either one of these for bitmap fonts, so I'm going to get rid of those. And then we also have page count and pages. So I think this structure makes a little bit more sense given asset only, right? And then I think we'll have sort of another set of this that deals with the actual resource itself, which might vary from this, right? So like when we go to set this up in a resource, we're probably not going to have page IDs, or maybe we will. I haven't decided that yet, but now is the chance we basically have to redo that and kind of clean it up. Let's see. Yeah, but you can make cool games. You're talking, yeah. I mean, you can make really cool games with it. Yeah, it's heavy, unfortunately. How do you deal with multiple languages? Are you talking about localization? Because if you're talking about localization, we haven't got that in yet. It's a to-do item, but I do have plans for that. So we are actually going to have had to load 50k glyphs without doing any smart optimizations. So, okay. Oh, okay, you're talking glyphs specifically. Okay, we actually do handle that. So, if we were to do this sort of the naive way, let's see, do I still have... Yeah, okay, I do have it. If we were to do this the naive way, right, we could just generate a huge-ass bitmap font that is just absolutely gigantic, right? And I included this as this is probably going to crash this editor, I'm thinking. It might, right? This has every basic freaking symbol known to man when it comes to Chinese, Japanese, and Korean, right? So this is what that, what one of those bitmap fonts actually might look like in that case, right? So this has all of this stuff, right? And you can see a lot of them are really packed down here at the bottom. It's got, English characters as well, right? So we could do it this way, right? And this was one of the early tests that we did, where we just rendered every freaking thing out to a huge ass bitmap, right? And then we load this thing in, and then we have, let's see, I think it was Noto Sans. Was it this one? Yeah. And then we have this one, which has the massive list of all those records, right? Which this is probably where you were talking about, like the 50k records or so. Like, and this isn't even all of them, right? I actually pared it down quite a bit. So instead of doing this, what our system font does, or system font system, for lack of a better term, is we load the TTF font for it, and we generate glyphs on the fly as we need them. So we maintain an atlas, at runtime, and every time we need a new character, we add a new character to that atlas at runtime, and we generate that texture on the fly. And that keeps our atlas very small, but it allows it to expand to anything that we need. So I guess I wonder if I could probably show what this looks like on the old render doc. Give me a second here. So for example, this little bit right here, right? This is using a system font, this guy right here. So I'm going to take a capture of that. Right? And then let me go ahead and kill this. All right. And then if we go in here to our standard UI, let's see. Expand this and look. Let's see, which one? Oh, did I actually just happen to click the right one by complete happenstance? Yes, I did. Okay. So this is what that atlas looks like, right? So we kind of generate this X here, which is what we call our invalid or -1 code point. That's when we don't have a glyph to render. We output that one. I also add in all the standard ASCII ones by default. So these always get generated, right? So these guys always exist. And then after that, anything that we run into that's not in this list, and we keep a running list of code points in there, anything that's not in this list, we add to it as we need it. So we can see here that we added all of these on the fly. So, was it? Oh, you're right. I missed an ad break. All right, I'll hold on a second. Thank you for the resub, by the way, for 6 months. Thank you so much. I appreciate that, man. That really means a lot. Thank you, my dude. Much appreciated. Yeah, ads are lame. Can't get around them, but yeah, I really appreciate the 6 months. Thank you so much. All right, so I'm not sure how much of that you would have missed, but here's the draw call in RenderDoc. So essentially, this is our atlas, right? So we always include like a -1 or like a I don't know what to render here. So here's the default, right? So we always include that. We always include the standard ASCII characters, right? So the numerics, some basic punctuation, capital, lower, slashes, crap like that, right? And then after that, anything that's not actually included in that initial list, we keep a running tab of what code points have been added, and as they come up, we go ahead and add them. And so this allows us to keep the atlas as small as possible, and then we can still kind of render it the same way that we would render a bitmap font, for example, but it allows it to be very flexible. So this I found to be a pretty flexible way of handling that, and that's how we handle multiple languages, right? We just have to have a font that is capable of handling all those languages, and then that's kind of what we do. We could do it sort of the naive way of just doing, which one was it? This one. This, right? With a huge ass image, but that's obviously not ideal. And so this will generally have more space in it than we'll ever need. And if we need another page, we can actually generate another page, right? So this is kind of what we're working with, and when it comes to internationalization and text rendering. The only thing that this doesn't support is, there's two things it doesn't support. We don't have right to left support, and we don't have, I forget what the term is, where you have characters that connect to each other. So in Arabic does it, for example. You have characters that run into each other for certain combinations, right? You used Harfbuzz for that? Yeah. Is it a ligature? Yeah, maybe that's it. So I don't have that support in yet. But maybe one day. Right to left, I don't think is going to be hard. The ligatures are going to be harder. But that's basically how we handle that, right? So we just add these things as needed. And then we have one of these atlases per font size. Now, when we switch to using signed distance field, we probably won't have to have one of these per font size. We'll probably just render one that's at a decent size and then can use that to scale appropriately. But for now, this is what we do. We basically just have one for every font size that's used, which isn't really all that much overhead, to be honest. But yeah, I hope that makes sense. In terms of the actual localization itself, when it comes to strings, that'll be a whole separate thing. All right. Cursive, I guess. I mean, there are some fonts, I guess, that do it, right? Like, there are some English fonts that do it too, I think. Like script fonts and stuff like that. But yeah. All right. So, we have these. I think this is everything I'm going to need for this. So, when we're dealing with the type of asset, we are going to use the kasset bitmap font. We're going to say typed asset equals. We'll just cold cast out asset to that, right? So that way we could just kind of work with that as we go. I suppose we could zero it out. It's not that big of a deal. Typed assets, and then size of kasset bitmap font. We don't have this included, so we'll get that. Let's see, did it do it? There it goes. All right. Also, we don't need this. I don't think I'm going to need a search. I'll leave that one there for now. D-array we might actually need. Actually, I think we're going to need that for the glyphs and kernings. That's fine. Core render types. I don't know if I'm going to need that. Case and parser we don't need. Case string I'm probably going to need. Render type utils I don't think I'm going to need. Okay. All right. So instead of file system readline, we are going to want to use something to actually proceed through this text one line at a time. So I actually have, let's see, I did this once before in, I believe it was the OBJ importer, or it might have been the MTL importer. Let's see, MTL serializer maybe? I think this is what did it. Yeah, here we go. So we do... I should have opened this over here. MTL serializer. And then over here, I want this guy. All right, so essentially we have to do this same thing. So I'm actually going to copy pasta this. Let's see. I guess we can take all of... Well, I guess we don't really need anything but this. Okay, so we have here that, and then we have the start from, line length. We have line length, we have line buffer. Okay, so it's just going to be start from. There we go. Okay, so instead of MTL file text, it's just going to be file text. And we want that to go to line length, which in our case, we just want to be AU32. All right. And then line. What are we saying that line is equal to string trim? I guess we don't really need to trim the string. We don't really need to do that. We don't really need this either, to be honest. All right, so we skipped blank lines. And now here is all of our typical processing stuff. So we want stdio for scanf because I don't have my own version of it yet. All right, so we have this verify line macro here. What is verify line doing? Okay, so that must be in the bitmap font loader. Oh, we have it here. Let's see. If actual is not expected. So... Oh, we're just verifying the number of elements read. I suppose that's fine. We can go ahead and take that. We'll go ahead and slap that right here. Okay, so the first thing that we're trying to read in is the info line, which is this guy. So we read in the face and then the size, bold, italic, char-set, all that other crap. So instead of out data, this is going to be typed asset and then just face. That's a kname. So we're going to have to do this in 2 steps. So we're going to do, let's do a character buffer. We'll say face buff. And let's say 512. Sure. And we'll just go straight into that. So face buff, data size equals 21. So that's the font size. So that's good. That is going to be directly into typed asset size. So we can read that directly there. The next thing that we'll do here is, now that we have this extracted to a string, let's actually do just because I'm paranoid. Let's do face buff size of char times 512. And then down here, we're going to convert that string into a kname. So we'll say typed asset face equals kname create. Oops. And we're going to pass face buff to that, and then we'll get a kname. All right. So the rest of the stuff we don't care about. Yeah, I think we can safely ignore all that other stuff, I believe. Maybe not, but for now I'm ignoring it. Let's see. I'll be a happy volunteer to writing PTBR translation. Brazilian Portuguese for Kohi games. Awesome. I appreciate that, Taman. I might take you up on that too. When people say that C++ is slow to compile, is it because of including STL headers, or are C++ compilers inherently slower than C compilers? Both. So, obviously, the STL uses a lot of templates, and templates are slow to compile, but also C++ is slower to compile in general because it has to do more, right? So, naturally, it's going to be slower. That's just the fact of the matter. Okay. So I think a lot of this is going to just be, unless we're dealing with strings, which I think that might be the only string that we deal with. I think all the rest of this is just straight up extracting stuff. Oh, the page is going to have a string. Okay, but the rest of it's going to be pretty easy. So these are common. So this is our common properties. So instead of out data, we're going to have, let's see. Typed asset. And then there we go. Okay, so verify line. All right, and type assets, pages. Okay. Incidentally, I might actually create like a array utility to handle this stuff. So I'm not having to call this like all over the place. I probably should have done that a long time ago. We have dynamic arrays, right? But we don't really have fixed arrays. They're just plain old C arrays, which it might be nice to have a container that holds that in the size and all that kind of stuff. So I might be creating that sometime soon too. Okay, so that takes care of that. The characters line, again, is just going to be most of the same kind of stuff. Typed asset. And then, typed assets. And then that, and then this should be kasset bitmap font glyph. Typed assets, rid of data. All right. And the reason we're splitting these out will become apparent when we go to do the resource system. So this is going to be kasset bitmap font glyph. Typed assets. Okay. Let's see. So that's reading in the character line. The page line is going to be, what did we say? The bitmap font page. I think this is going to be kasset bitmap font page. Typed asset pages. And then this file, which is this guy here, is a string. We need to treat that as a kname though. So I'm actually going to do the same as what I did up here. I'm actually going to grab both of this, right? So let's put this here. And we'll call this file buff, right? And then instead of going to page file, we'll go to file buff. And then down here, we'll say page, what did I say? Typed, what was that before? Yeah, it was page file. Page image asset name, we're not calling it file, right? Will be kname creates, and then file buff. Strip the extension, right, because we don't care about extensions when it comes to asset names. So that is needed. So we should probably wait to do this until after that. So this is going to be, instead of page file, this is going to be file buff twice. Right, so we have the destination and the path are in there, right? So basically just does it in place is what we're saying. And then since we're removing it from the end of the string, it's not a big deal. And then we go ahead and create the name here, and we're good. Kerning is going to be pretty straightforward. So that's going to be typed asset. Probably should have just done find and replace on this. It probably would have been quicker. In fact, you know what? That's exactly what I'm going to do. So let's say out data dot, and replace that with typed asset arrow globally. Much better. Okay. So this is going to be kassets bitmap font kerning. And this is also going to be the same thing. And there we go. Okay. So at this point, we should be good to go. Now, I believe we actually didn't wind up needing darray for this, because we have that information up here at the top. Let's see, that would have been on the chars line. Yep. Okay, so we already set that up there. And then I believe we do the same thing for kernings when we find that, because there's a kernings line and then kerning. Yes. Okay. All right. So all of that is done, which means we don't need darray either, or core render types. An included file. Empty file name. What happened there? Okay. Not sure what happened there. All right. So that is really it for our bitmap font deserialization, right? So we have our serializer. Let's go ahead and look up bitmap font serializer H. Let's get this changed because we had this stuff renamed, right? So we want bitmap font deserialize. Okay, so there's the serializer. And all we should need to hook up now is a asset handler to load this up, and we should be good to go. So what I'm going to do is, since our asset handlers are mostly alike, I'm just going to use one that we already have. Our asset handlers live in the runtime. Right, so let's go to I guess I could use I think the height map terrain one is going to be a good one. So instead of height map terrain, obviously we'll just say bitmap font and bitmap font. So do that there. And then load up the C file, do the same thing. Right. Incidentally, I simplified these a lot as well. So really all I need to do now is hook up some basic function pointers and then handle with releasing the asset, and that's it, right? That internal step of actually loading and stuff has all been offloaded. So this needs to be bitmap font and oh, we didn't create this yet. Okay. Let's set this to binary for a second so I can quickly and lazily navigate to it. I think we did this already for system font. So let's just nab this. And go above all of the, let's go right here. This is the string representation for the font type. So we have bitmap font, bitmap font, right? So we can undo that. And then oh, wait a minute. We don't have a serialize there. We only have a deserialize. Notes. Not set as serializing to this format makes no sense. If I could spell sense correctly, that'd be awesome. Okay, and then the only thing that we'll have to do here is a little bit of memory cleanup for the asset type. All right, so I guess what we need to do here is, I think there's only a couple of arrays we need to clean up. I think that's going to be kernings, glyphs, and pages. Yeah. Okay, so I guess let's do pages first. So pages and page count. And see, this is where it would be really nice to have like an array to just like clean it up. Because I'm kind of getting tired of writing this over and over and over again. I guess for the sake of completeness, let's just finish this out this way, but we'll do pages, and then size of, right? And this is going to be bitmap font page. And then we have page count. So we have page count goes here, and pages is here, right? And then we have this again for glyphs. And glyph count. Glyph counts. And then, of course, make sure to get the type correct. And then kernings. And kerning count. Right, and then this should be kernings. Right? And then we can just zero memory the whole thing. Typed asset, size of, bitmap font. Done. Right? So that's our cleanup of the asset. Thought I already had, didn't I already have asset types in here somewhere? Thought I did. Probably in the header. Yeah. Okay. So that's done. And then we have to go into the asset system and add our handler. So include assets, handlers, bitmap font. Come down to where we load or register our handlers. So we'll say, just copy paste that. Bitmap font create. And then this is going to be bitmap font. And now the handler is registered and ready to go. So we've got our serializer done, our asset handler done. It's registered with our asset system, so now we can load that. So now we can actually come over and check that item off in the to-do. Right, so this is done, this is done, this is done. And by extension, that's done. All right, okay, so we've got all of our basic stuff done. We've got some cleanup stuff to do. I'm going to skip audio formats from now. We're going to come back to that. Some things like this I'm going to do in the future. This I don't have to do right this second. We can do that after we switch everything over. Features, folders are going to be in the future. Static meshes. Okay, this is actually something we should probably hit sooner rather than later. It's not going to be a very large item, but it's still going to be something we need to do. Okay. Our list is narrowing on the asset work we have to do, which is good. Okay. So I think... important question, will Kohi support soft body dynamics for female characters? I know what you're talking about. If you want that, animate it yourself. I won't be adding that specific thing, no. Top priority, right? Well, let's put it this way. If I were to add it, it wouldn't be specifically for that, but it could be used for that. I've actually been doing a little bit of research on animation blending with physics, so that should be an interesting part of that, I suppose. He wants the bouncy physics. Yes, he absolutely does. 100%. That's from Lake on YouTube, by the way, saying that. So you guys know who I'm talking about. Top priority. Yeah, that's... I mean, I don't know from Lake. You tell me, is that top priority? All right, let me see if I missed anything. I'm going to just build real fast. Okay. Bitmap font, deserialize. Did we not? So we exported it. Oh, that's actually pretty amusing. We didn't include the actual header file. So because we didn't include the header file anywhere or within this, it doesn't know that the thing actually exists. Include set bitmap font serializer H. You think it should be at least the top 3 to do? I mean, I don't even have regular physics yet. So I think regular physics come first. Rigid body comes first, for sure. It's a good compromise. You're not wrong. All right. So we build. I guess this is probably. I don't really want to start ripping into the resource system tonight. Just because that's going to be a whole other discussion, right? So I think what I might do, maybe I'll create that array thing I've been talking about. Incidentally, I did start on something on a separate branch that I want to put in, I think, maybe after I'm done with this resource stuff. So that we don't have to... Let me go back to... When we free, basically, so we don't have to include like all this stuff. All we have to do is include this. I've improved the tracking. I'm improving the tracking on a separate branch. But of course, it's going to break the entire code base when I do that. So I kind of don't want to put it out there yet, and it's also not done. But we'll be getting that sometime soon too. So the free interface is going to be a lot easier to work with shortly. Well, we could discuss the game idea, but the problem is the voting hasn't concluded yet, right? There's still 5 days left on it. Which, incidentally, if you haven't gone to the Discord server yet, I'll drop the link again in chat. If you haven't gone to the Discord server yet, go to the polls channel and vote. And choose which one of these things that you want to be the first project for Kohi, or whether there's not one at all. Obviously, I don't think this one's going to be... I put this in there as kind of a joke, but I think this is the direction we're going to be going. But if you want to see a big game instead, go and vote for it, you know? But yeah, there's 5 days left on that. I don't think that's really... hasn't moved much since I took that screenshot, so... okay. So yeah, until that voting is concluded, I don't really want to necessarily jump into game ideas yet. But we are going to jump into that after the voting's concluded, so next week. Okay. I guess, yeah, let's add a quality of life thing in here. So in core, we have... we have our D array, which I saw something on a Thanos stream earlier that actually kind of got me thinking about the way that I might want to write this. Which, by the way, if you're not following Athano, I don't know if he's in here right now, probably not, but... yeah, if you're not following Athano, you should definitely be doing that. But he actually had kind of a clever bit of a solution in terms of setting these arrays up. So I might do that on top of this, this array that I'm talking about here, if it makes sense to do. We'll see. I want to get the basic implementation in first, and we'll go from there. So I want to keep sort of a similar idea of how the D array works, except the difference is going to be our array is not going to be dynamically expanding, right? So we're not going to have this push or resize or any of this stuff. All it's going to be is a container, essentially, that maintains how many elements it has, what the length of each of those or size of each of those elements are, which I guess would be stride, and then that's pretty much it, right? So that way, when we go to destroy it, we don't have to like memorize all that stuff and carry it around. It'll also make it a lot easier when we're dealing with that, because we can actually get those properties directly from the array itself, and not have to pass, a pointer and then also a count around. We can just pass the array. So let's go ahead and create a, I guess I'll just call it array. That seems kind of basic, but fine. Pragma once. And so I'm thinking, I want to include defines. And then I'm thinking type def struct. And I'm going to call this array. And all this is going to have is, should I do this as, I'm going to do them as U32s. I'm going to do capacity and U32 stride. And then block of memory. That's it, right? So that's going to make it very easy for us to sort of iterate this stuff, right? And because we have all the information we need, I guess maybe instead of capacity, let's go ahead and say length. The only thing that would suck about this structure that I'm not 100% sold on yet is we can't just, create an array and then immediately be able to use it, right? Like we can't index into this thing, right? One thing that we did in our D array was we sort of have our block of memory that the array is in, and then put the header information right before that, right? So when we set up the allocation, we have this sort of header information, and then the block of array memory comes after that, and that's what we use. So I guess it's really more of an API thing. I suppose we could say data, right? And then instead of let's see. You didn't vote for the big game because you're afraid its scope might be too large for you to handle yourself, along with developing the engine at the same time. I mean, it would be so. The large game would be something that I can handle on my own, right? I may wind up bringing in some art from artists and things like that, right? But it's not going to be so gigantic that it's going to be like I'm not creating Grand Theft Auto 6, right? It wouldn't be something like that massive in scope. I'm not insane. All right, well maybe I'm bordering on that a little bit, but yeah, I know. I might have to take that back. I am writing a game engine from scratch. Maybe I am insane. So what I think we could do for this, that might be let's define we'll say, how do I want to do this? We're going to use a little macro trickery here. So let's say I want to define array. And I want to include the type and length. Right? And so to that, I want to then say, oh, can I not do an underscore? Interesting. I thought I could just do something like that. Can I not do that? Oh, I think I have to do that. Yeah. And so basically what we want to do, is it pound for, or is it type pound? What is the actual? I think it's just, let me look at logger. I can't remember the actual stupid syntax for it off the top of my head for some reason now. I'm pretty sure. I'm pretty sure. No, we didn't do it there. Yeah, it's double hash. To spit that out as a string, essentially. It's double hash and then the type, right? I think. I think that should be valid. So essentially what I want to do is I want to take the type name in here. And say that is part of the array type that I'm type defing here. I feel like I've got that syntax wrong. And I don't think it's that. I think it has to be this. But I feel like that's also wrong. Let's see what it expands to. Yeah, I mean, well, I'll get that here. So like if I do, for instance, if I do rubbish, whatever, and then I do U32, or I should say array U32, with a length of 4. It's just putting type there. It's just literally saying type array. That's definitely not right. I could have swore it was that. I feel like I'm doing something dumb here syntax-wise. It should be type double pound array. Is that what it is? I don't write these very often, so I always get tripped up over it. Like that. I do have it backwards then. Yes. Right, and then instead of a void pointer here, right, you would have type pound, right, data. So it should give us, right, the actual data in that actual thing, right? So we have U32 array, and then U32 is the data type internally here. And so when we create that, all I need to do now is figure out how to actually create one of those and return it after it's type deft. You don't think the pound is necessary? Might not be. Yeah, see, it just takes it literally if I don't have it in there. That's what I was thinking. Yeah. It doesn't expand it if I don't have that in there. It just takes it as type array. So I guess let's see. I guess I would just expand this then to then do I guess it would just be how would I set that to? Because I don't want the type def in line like that either. And this wouldn't necessarily be that. It would actually be length. Oh, I don't want that as a string. I guess I would just do length then. Yeah, there we go. Oh, forgot to get rid of the space. That should be... Why is it jamming all that together? Maybe I just need that. No, that's definitely not right. Do I just put type? Okay, so for there I can put type. But I can't as part of the type def. Oh, and because I named this length, it's actually picking this up as that. So I need to do, I guess, len to have length separate. Have to remove the double pound after, yeah. So this is close to what I want. The problem is I don't... I want to also be able to say that this is a... I want to be able to loop an assignment into this, right? So I want to be able to say, I don't know, a name as well, I suppose, right? So like, I guess I could say name, right? And I could say test array or whatever, doesn't matter. And then the name would be, how would I do that though? Because if I wanted to include, if I want to declare this and then immediately say after it, name, and then after that I should be able to say, you know, test array 0 equals 34, whatever. I guess this should be test array data. Yeah, that works. And that comes out as a U32. And I could then query test data for length and stride, which stride would be... Well, actually, do I even need... Do I even need this then? Because this isn't actually even created... I don't even think I need this. Right? Because then I don't have to actually destroy it either. Because this is now all done on the stack. And I have everything I need right there. Yeah, I suppose it's a good point, Coffee Lava. I could just literally get rid of... I guess I don't need the name, right? I could do... that. Right? Is that... What am I missing? Oh, I called it test name, not test array. Derp. Dingus-oriented programming for the loss. Okay. Yeah, it's a little bit cleaner, actually. And that would extend any type that I need. So it'd make it a lot easier to deal with, I think. I guess. But that's a hell of a lot easier than the other way I was doing it, I suppose. I don't know. You also don't need the data field? Yeah, exactly. Then it could literally just be simplified. Oops. It could literally just be, well, but this doesn't ultimately solve the issue I was really after, though, which is like, this is really no different than like creating a standard C array, which is not really what I want. Isn't it going to conflict if you want different sized arrays with the same item type? Yeah, that's what I'm worried about. And I think this isn't totally what I want anyways. What I really want is something like this minus the dynamic allocation, right? So think like like std array, for example, right? It has like a, it's just a struct essentially with a capacity and a size. I don't necessarily need this. I don't need it to be allocated on the stack either. I need to store length then. Exactly. Yeah. So I think I was going the right way. I just kind of took it too far in one direction. So, oops. So I need that. And then U32 length. I think I'm getting more fancy than I need to here. I think the cleverness is what's tripping me up. I'm just gonna make just a simple dynamically allocated static array. It's usually just a struct wrapping around a C array, no size, capacity distinction. Yeah, exactly. It just needs to know. I guess it doesn't need to know. Well, it would be nice to have, the length of items in it, right? That's what we're ultimately trying to solve. Is that we have a struct that's basically, typedef struct array, right? And then U32, we'll say length, and then, some sort of data, right? And that just gets, that's what gets passed around. Oops. Include defines. Right? And so, ultimately, to set one of those up, I would just do something similar to what I do in darray, where I'd have like a, I guess in this case it would be, I guess I could do pretty much the exact same thing I do with darrays. It's just not have anything except these two. And I'm thinking, this would have, oops. So we'd have like a, array create, right? Well, and actually, we would want stride too, because our array create would have U32 stride, U32 length. And then that would perform some dynamic allocation to get this, right? We could also even say, maybe the memory comes from elsewhere. I'm not going to worry about that for right now. But we could say length times stride to get our data size, right? And then we have our void array destroy. And all we have to do is pass to it, the array. I guess we'll call it that, right? And so the idea would be that whatever we call this, we would return the void pointer that has, that is this data here. But just before that void pointer, as part of the overall allocation, this header information will be included. And so essentially we just move back that many bytes in memory to get the header information, just like we do for the darray, to get that kind of stuff. And then you could just be like, well, void array length get, I guess, void array, right? And that would be U32 right? And if we wanted stride, we could get that too, but I don't think we'll need it. And then, this is all we basically need. Also alignment on create, yeah. Although our, we would do that anyways when we go to allocate the memory. We'd make sure that data itself is aligned. STD array doesn't need to store the length because it's a template parameter, so it's implicitly stored there. Yeah, exactly. We don't have that luxury. Which is what I was kind of trying to work around, but it wasn't really working the way that I wanted it to. So the nice part about this is that we can literally just have an array of any type, right? And we just pass it around, but we can extract this data from it now. Versus having to use a D array to do it. And the reason that I have this one with an underscore is because I would do, like a define array creates, where you take in the type, right, and then the length, and then that would call array creates doing size of type and then length. Right? So that way we don't have to do size of in our code. We could just get it here for free. I think that makes sense. Can't you just do the old size of XS divided by size of XS0 trick to emulate a templated size? I guess we could. I'm trying to think if there's any reasons why that wouldn't work. That's the thing. Like if it was an actual array that we created it, like if we did U32 something 45, right? This whole thing has a size of 45 times U32. But if we just have this, right? Size of this is going to be 8. Because it's just a U32 pointer. So it's not going to know, if we create it that way, it's not going to know. These stupid spammers, I swear. Goodbye. You know what I mean? I think this is solid enough. I think I might be overthinking it, to be honest. And in fact, I don't even need this here. I need this here, and I'll call this array header. I don't need the data, right? I just need this stored in the header. So I'm going to take, let's just copy pasta all, actually, let me get rid of this rubbish. And then copy pasta all this. Right, so I think I was just trying to get too clever with it. And I don't think the cleverness is just going to pay off. So let's just keep it simple for now. And I can always wrap some macro weirdness around it if I think of something later on. All right, so when we allocate this, we're going to need include. Let's see, this is going to be memory, kmemory. And we're going to do a kallocate aligned. The size is going to be stride times length plus, actually I'll do this. And this is going to be plus size, I guess I don't need this, size of array header, right? Alignment, we're just going to say, let's keep it 16. And we'll do memory tag array, right? So that's going to be the base pointer, right? So the base block of memory is going to include the header, right? So the header is going to be array header equals, we're just going to cold cast to array header the base pointer. And then we can set the header. Then we can set the header length to length and header stride to stride, right? And then we'll have that information down here when we need it. And then we will say that array equals u64. We'll cast base pointer to a u64. Whoops. We will add to that size of array header, and then cast the whole thing back to a void pointer. And that will give us our final thing for the array, which we can return. Right? Okay, so there's that, and then when we go to destroy, we need to extract the header first. So what we want to do is get a void, actually I guess we could say array header is going to be, we're going to take, again, we're actually just going to do something very similar here. Let's just copy this. So we're going to do array header, and we're going to take array minus the size of array header, right? So we'll take array, cast that to u64. From that, we're going to subtract the size of array header, take that whole thing, cast it to array header, call this header, and now we have the header. And then we can do k-free aligned. The block is going to be header, right? Because that's the base block of memory. The size is going to be header.stride times header.length. And we want to wrap that whole thing in parentheses. And then do plus size of array header. And the memory tag is array. Oh, I forgot the alignment there. The alignment in this case is 16. 16 should be more than good enough for anything that we're going to use. Yeah, and that's it. We free that and we're done, right? So the length, the array length get is easy. We do the same operation to get the header, and then we return header length. Boom, done. I think having an actual array darray struct would be nice, because now you have ambiguity when you use a pointer as an array on the base code. Is it supposed to be dynamic or static array? That is a problem with doing this. Yeah, you're right. And the way I've gotten around it for now is whenever I use a darray, I mark it as a darray, like as a comment, which isn't great. I will grant you that. I could do it as a struct, but then that's kind of annoying to you know, because then you have to say like dot data all over the place or whatever. So I don't know. I don't know what the better solution is there. Let's see. Let me catch up on some YouTube comments. Looks like if you want to go insane, try to memorize this function. Ooh, that's a good one. I'm going to take a screenshot of that real quick. Actually, you know what? I'm just going to drag the chat over here really quickly, because I don't think there's anything over there that's going to... Yeah, nothing on there that's going to get me banned. Look at that function name right there. Gotta love Vulkan, right? Thank you for the follow. I appreciate that. All right. Hey, how have you been? Last time I was here, I believe you were fired from your job. Have you a new one already? I was laid off from my previous job. Yeah, I've had a new one since February. Technically since, well, yeah, February. Yep. But yeah, thank you for asking. Yeah, I did land on my feet when it came to that. Yeah, I got laid off in February. I found out about it in January. I got laid off officially in February. Which that definitely sucked. But thankfully I was able to land on my feet, and yeah, I'm at a new job. Technically it's an old job. So old new job, but yeah. Thank you for asking though. I appreciate that. Oh, Dr. Elliott comes in with a longer one. I'm going to paste this one here. Oops, or I'm not. Let me try copying that again. Yep, okay, it's a format. I'm not surprised. I was going to say it's either a structure type or a format. Look at this madness. VK format feature sampled image YCBCR conversion chroma reconstruction explicit forcible bit KHR. Man, did they not stop and think, like, maybe that's a bit much? Maybe we could reduce that just a skosh? Nope. Apparently they didn't. That's when operator overloads come in handy, just to overload. Yeah, I mean, if I was doing C++, I would operator overload it, no questions asked, but I'm not usually a huge fan of operator overloads, believe it or not. I think they're abused. But yeah, in some cases they do make sense. The format that Vulkan users use on a daily basis, sometimes it feels like that, for sure. I thought Java Spring was the king of long identifiers. No, Vulkan's taken that crown, I think. Just didn't remember no, it wasn't my fault, just didn't remember the word. Yeah, no worries about that. Yeah. It is what it is, you know? Yeah, don't worry about that whatsoever. I fumble things with wording all the time, and English is my primary language, so I have no excuse, but I do it anyway. Never worry about that here. I don't quite understand what it does, but I could probably get it if I had a few more words. Yeah, I know, right? All right. So this is, I think, the array structure that we're going to continue with for now. There is the problem about when we use this in code. You know, how do we identify this as an array of this sort versus just a regular, like a D array or a C array that we've created the old-fashioned way. Yeah, we'll have to, maybe we'll come up with a naming scheme for that, right? Maybe that's the way we handle it. Maybe we just handle it with a naming scheme, right? So like maybe if we go to use this in code, you know, let's do this real quick. So maybe if we go to use this for a regular C array, we'll do something like you know, U32 numbers, you know, equals k allocate blah 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 blah, right? So maybe if we do that, I'm just gonna plug stuff in here so the compiler shuts up real quick, right? Right. So maybe if we have just an array that we've created sort of the classic way, we'll do that. Maybe if we're using this new one, maybe we'll say U32 A numbers, right? And then that'll be our, you know, array creates, you know, U32 4, whatever, versus U32 dynamic array would be D numbers. Equals D array create, right? Maybe we do it that way. So U32. Maybe that's something we need to adopt, right? It's just a naming convention that gets us around that. Thought you wanted an array that wasn't malloc? No, because I mean, honestly, if I have, like, okay, so there's not a reason I can't just do, you know, inline there, like that, right, and be done with it. Because I got thinking about it, and I'm like, well, that doesn't really make sense to come up with, like, some fancy thing for that. I could just do this. I suppose if I need to pass it around, it becomes an issue, but I don't think I really need anything fancy for just like a normal array of this type. Apple Core Media has, ooh, that's a good one. You guys are gonna make me like compare these in length, aren't you? Hold on a second. All right, let's grab this one. Let's open Kate, right? And we'll do this one. So Apple Core Media has this one. Oh, not as long. All right. And then it also has another one. All right, let's try this one. Is that the whole thing? It looks like there might be something missing at the beginning because it just has a lower k case. Oh, I think it's supposed to be that. Almost, but still the Vulkan one's longer. Let's see this Direct 3D one here. Let's see if this one's longer. Who holds the record? I bet it's still Vulkan. Nope. Direct 3D wins. Let's see. I know some people that do int array 32, int array 64, etc., but I don't like doing that either. It solves all the issues with just the naked array, though. Yeah, exactly. Yeah, I don't know. I'm gonna have to think about that for a little bit to see if I can land on anything that's better. But I think for dynamically allocated arrays, which have their uses, because I don't necessarily want everything on the stack, I think this is gonna work just fine. Superior graphics API, hands down. I mean, if it comes to, name length, then absolutely. All right. Well, the Vulkan's got wider letters, you think? No, because this is a fixed width font. I think. I don't know why it wouldn't be. Let's see. Is there a I don't know where the actual configuration to set this stuff up is in here. But yeah, I'm pretty sure this is fixed width, right? Like I could copy this into here. Like Vim is not going to yeah. Direct 3D wins for sure. Oops. All right. If you need stack allocation, you could try alloc. Yeah, I mean, that's not all that portable, though. Not every platform has it. I know a lot do, but I suppose I could do that, but like I feel like alloc always feels kind of dirty to me for some reason, and maybe I don't have any justification for it, but it always just feels dirty. All right. So with all that said, it is late, and I do need to get up for work in the morning. So I am going to be wrapping up the stream here, and we'll continue on with the resource system half of this tomorrow, and we'll start hooking up some of that stuff, one asset type at a time, and go from there. Alloc does heap allocation past a certain size. Yeah, exactly. And I don't know if you have control over what that size is. I don't think so. All right. So, with that said, let's go ahead and find somebody to raid. Thank you for the follow, by the way. Okay. Oh, here we go. I know who I'm going to raid. We are going to raid Kuju. He's making a game in Jai called Fat Goblins, and it looks friggin' awesome. So, yeah, definitely a very cool project that you guys should check out. I'll drop a link on the YouTube side as well. But yeah, that's going to do it for the stream tonight. Thank you guys so much for joining me here. I appreciate you guys, and it's been a lot of fun, and we'll pick this up on the next streaming session, which should be tomorrow night. So I will see you guys then. Yeah, that's about it. If you haven't already, also, I would appreciate any follows or whatnot. Follows on Twitch and subscribes on YouTube. Thank you so much, guys, and I will see you tomorrow.